Okay, students, in this brief video, we will be talking about computational resources needed for running large language model locally on your PC. Here you see two windows. On the left side is the task manager, and on the right side, I opened the command prompt. For running local large language models on your computer, we mainly need GPU, the graphic processing unit, and if that is not available, the large language model will use the RAM or the memory, the random access memory, or the memory of this is the RAM. This memory on your PC. And of course, the central processing unit is the unit where the whole processing is taking place. As you see already now that I'm uh, recording this video, some processes are in the background, and you see the percentage of the RAM that is being used for recording. And now, as I said, the main part that will be used for running a large language model locally on your machine, that is the GPU. But unfortunately, I do not have a dedicated GPU, so my computer will be using the RAM or random access memory, the main memory of the computer of the machine for this. Now let us run a model. I will say I'll first list Olama list. I will first list all the models that I have on my computer, and you see these models. Among these models, I can run Llama 3, which is 2 GB, and Granite 3.1 dense, which is 2B, and it's a 2 billion parameter, and it is also a 2 billion parameter. The size for this is 2 GB, and this one is 1.6 GB. So let us choose Llama 3 to run right now, and I'm doing Control C just to copy this, and then I will say Olama run, and I will paste the name of, I just pasted the name of this model. So now, now look what happens when I run this large language model locally on my computer. Now look at what happens here. I'll just hit enter, and then as soon as I hit enter, you see the progress of running this, and at the same time, you'll see that I started using my memory within the computer. The random access memory is, some part of this is allocated. So this graph went up. So, and I have the model now running on my computer. Now, whenever I do a processing on this, you will see changes in the CPU, in the use of memory. So look at this and also to the graph. So I will say, tell me about the importance of public health in 250 words. And I will just run. And now look, as soon as I enter this question, the processor all of a sudden shoot it to 100%, and you see the graph going all the way up. So the model locally running on my PC will tell me about the importance of public health in 250 words. And now this is generating the response, and as long as the response is being generated, you will see that fully 100% of this memory that was you saw that increase a little bit. Now, part of that, like the 100% of that is now being used for generating. And as soon as you see when the response ends, then the CPU comes back. Now, what I will do is I will just now quit from this model. So I would say in the command prompt, I would say, okay, bye. and I will leave this model. Now you will see that it's not very visible here, but now I left the model. Some of the processes are in the background, which still keeps the memory um, occupied, but basically we quit the model now. If I uh, run it again, let's run it again. Ulama run the same model, and you will see that the chain, okay, because it's the same model. I'll just say by, I will run another model, Ulama. I will list the models that I have. And this time I will run the Granite 3, the 2 billion parameter model. I copied it, Ulama run, and let us run this one. So now you see this notch here. It means that it left that model and it started, this is slightly less than that, but you see the difference. You see after the notch, it loaded the other model, and now it's a little bit lower. It's not visible very much here, but you will see in terms of the use of the memory of your computer, the random access memory. So this, in general, we need this GPU, and if it is not available, then the computer will start using your RAM and the CPU for processing any questions that you will have. That's all for now, and I'll say bye from this model, and thank you very much for your attention.